Thanks to everyone on the RAV4 EV list who have helped me with technical advice and even just cheering me on troubleshooting this particular failure on my RAV4 EV. But as Peter said, I do want to make sure that my logic is sound on the way that this was tested. I basically went through the RAV4 EV repair manual, so I figured I would actually create a little video to show what my methodology has been in terms of actually troubleshooting this thus far. So this is an interior view of the power control unit with the cover removed from the manual. These are the cables going down to the AC motor from the control unit and the inverter. And these two terminals are the leads coming, the DC coming from the pack. This is AC. This is the DC coming from the battery pack. So basically what I'm having is an internal resistance fault, and this module right here is the ground fault module that determines whether or not any current is leaking out of the system. So the way a ground fault detection works in general is it measures the output of the battery pack by a sensor that's actually down in the battery pack, all of the current that's leaving the pack, and when the vehicle's in motion, all of the current that's going into, I believe, the actual inverter, the motor inverter, and to make sure that all of the current that's coming out of the battery pack is actually going into the motor or is otherwise accounted for through all of the systems that the high voltage system is responsible for. If there's less current coming out of the system than is going into the system, that means the current is going someplace else, generally to the ground of the vehicle, and that creates an electrical shock hazard. So the ground fault module then sends a high signal on the leak. I think it's called leak EV, which means that there is something wrong, and that tells the battery control to shut down the system relays and say, don't let any more current come out of the batteries because we can't account for where all of the current is going. Now, this is consistent with the fault that I was getting, which is the insulation resistance malfunction. So if you actually have a cable that, say, the insulation has worn off on it and some of that current is leaking through to ground, that would be consistent with this fault where actually there's a ground fault. So what the repair manual has you do is check the insulation resistance with something that's called a megger, and what it does is it provides a high voltage to the cabling, and it checks for this to the ground. It checks for current going from the megger through the cabling back to the megger by way of the ground. If that's happening over a certain amount, in this case 410 kiloohms or more, or I should say that's the resistance. The resistance should be 410 kiloohms or more. If it's less than that, then that's an unacceptable amount of leakage through the insulation. So that's the way they do it. Obviously, before you ever remove the cover of the power control unit, is first have experience working with high voltages, particularly high DC voltages, which is a little different than AC, and have all of the appropriate safety precautions, rubber gloves, eye protection, having things on the fender. But the most important safety precaution of all is to remove the service plug, which is located behind the driver's seat on the floor. What this effectively does is it breaks the battery pack in two, so there's no current path through the entire battery pack. Once you've removed that, the manual says that you need to wait 10 minutes to let everything that may have charged up in the system to discharge. And then once I go into the power control unit, I do some voltage checks on various things just to make sure that there is no voltage, actually on this one, there is no voltage present here to ground, here to here, and here there shouldn't be, but here to ground. All of these different places, these key places, to make sure that there's actually no voltage present before you start connecting a megger. So going on to what the repair manual has you do. The first thing it has you do is it checks to see how the insulation resistance is from the motor output terminals to the case of the PCU. And the resistance of each of these cables should be more than 410 kiloohms. And in my case, when I checked this, it was not. It was less than 100 kiloohms. So that means that it's no good, and you move on to the next step, I think. So then what it has you do is it has you remove the cables to the traction motor, and then I capped these off so that they're not touching anything. And then you're checking these terminals here. Now, that has isolated the cables going down to the traction motor. So if the fault existed in there, then you would suddenly see your resistance go up to the 410 kiloohms or more. In this case, when I checked it here on all of these, it was still less than 100 kiloohms. So that means that it's still not good, everything. And as you can see here, is if it had been okay when you were checking this side of the traction motor cables, then it would say check the resistance between the traction motor cables and the traction case. So that means that your fault is beyond these terminals in the cables going down to the traction motor, I think. But in my case, it was no good, so you go down to the next one. And then what it has you do is it has you check the resistance at the battery input leads, which is on the right side of the PCU case. And then in my case, it was still less than 100 kiloohms, so that means that it was no good. And then you come down and then you disconnect the battery input cables. And so now you've taken the battery pack out of the system, you've taken the motor out of the system, and now you're checking the insulation resistance really for everything that's in the power control unit, the suitcase as they call it, and a few places where it comes out of the power control unit for the air conditioning and the heated windshield, that cabling as well. And so when I tested this, it was still no good. Just out of curiosity, I actually checked the resistance of the battery cables to ground, each of these both to ground, and they were both over, I think they were infinity on it, but I think they were at least over 1 mega ohm. So that indicated that there was no insulation breakdown in the battery pack, which was good, I think. So moving on, it was still no good. I go to step 5, and then what it has you do is remove the AC compressor connector, which is actually located on the left side of the PCU. It's actually over here on the outside. There's 2 orange connectors there. And what they do is they take some of the high voltage out of this case in order to run the air conditioning. And they want to make sure that it's not actually the air conditioning, so you remove those, and then you're checking again the resistance on these input terminals of the PCU case. And in my case, it was still less than 100 kiloohms, which is still an insulation failure. Should not have that little resistance from the cabling to the PCU case. So, so it was still no good. everything. And so then the next step is you come down and now you remove the noise filter, which is up on the firewall. These two connectors get disabled, and that eliminates the windshield as a possible fault. And with those were removed, you check it again, and now you're actually now checking it in two places. You check it at the input terminals, as I've done before, and then directly below the fuses, kind of behind the battery control unit, there is I'm not sure if it's actually the battery control unit, but there's the relay output terminal for the heated windshield. So you check it there, and again, the resistance from these points to the case of the PCU should be 410 kiloohms or more, and it's not. It was still under 100 kiloohms. So then, moving down, then it has you actually disconnect the noise filter input connector. So now you're disconnecting this whole assembly down to the PCU case. It's kind of right back over here. It's kind of hard to get to. And again, you check it at the input to the PCU case, check the insulation resistance at the relay terminal, and in my case, it was still a fail. And so then moving down to the next one, then they have you disconnect the ground fault and the heated windshield controller. And as Peter said, the heated windshield controller also has the ground fault circuitry in it, and that is actually located right here. The data, the low voltage cable comes into the back of this. The high voltage cable, all of these are orange cables, comes in right here. And what it's doing, I presume, is it's sampling the high voltage at various points in the car, within the car. And it may actually be sensing some things. Looks like there's a Hall effect sensor at the output of the battery pack and a Hall effect sensor going into the inverter. So what we've done there is now we've removed this cabling. So now when I checked the insulation resistance from here to ground, I suddenly had 500 kiloohms, which meets the test. It is over the 410 kiloohms. And that means that all of this orange cabling in here is all above the threshold, which is acceptable. That tells me that all of these other cables are good in terms of their insulation resistance to ground. So that's the way I was able to isolate this. And as Peter had said, knowing what I was doing, I next wanted to see if, in fact, if I remove this ability for this module to sample this temporarily, just as a test, I reconnected everything, reconnected all of the things that I had removed before, and except for this one connector here. Left this connector on because this connector needs to be on in order to communicate with the car's other computing systems. And what I did is I basically removed the ability for the ground fault module to actually sense any problems within the high voltage system. And at that point now the car would charge. I wound up charging it all the way up to 100% because it was down to like 28%. And I didn't like the idea of the batteries staying that low for weeks on end until I actually solved this problem. So that's the way I was able to isolate it down to this module. And what I presume is that there's different high voltage wires that come into this module. I presume, based on my experience with other electronics, is that there's some comparator circuit, usually from the output of Hall effect sensors, but as Peter said, I haven't actually understood how they're doing it in the RAV4 EV. But basically, again, as I said before, they're comparing the current coming out of the battery pack and the current going into all of the other systems on the car and making sure that those are basically equal. If they're not equal, that means that current is going someplace where it's undesired. And that's why this module is responsible for shutting down the car. And in this case, shutting down the charging. So that's the methodology that I used. Anyone who has experience with this, I would love to have your feedback on it. I also felt like that this video might be helpful for somebody who is feels confident enough, feels like they have the experience enough to actually dig into all of this. Um, and I'll reiterate it again. The most important thing before you dig into anything inside the PCU case is removing this service plug, waiting 10 minutes, and making sure that no voltage is present at any of these terminals that you're going to start digging around in when you start doing those insulation tests. I also add an insulation test meter is different than a multimeter. What it actually does is it actually provides up to 500 volts. That's what Toyota specifies on theirs documents. It provides 500 volts to the wire just to make sure that none of that voltage is leaking over to the case. That's the way an insulation test meter works. So you have to have a little bit of special equipment. I didn't have one anymore. Last time I used one was in the Navy, so I actually had to buy one on Amazon. So any feedback, I'd really appreciate it. If you've actually watched the video all the way to the end, I really appreciate it. But you can let me know if you have any clarifying questions. But my next step is to kind of get into that module a little bit. But then again, also Sergio actually at Battery MD indicated that he may have one, so I'll write him also and see if I can go about getting that module. Thanks again for watching. I hope that all made sense.